In this video, I will solve an equilibrium problem from engineering statics. So I made a cool stuff. So this is a pumpkin, and I have a cable. It's a rope actually. So a rope. I am holding this pumpkin, say this way. I am holding this pumpkin this way. So my this hand is horizontal, this cable is horizontal, and this cable is inclined. And then my pumpkin is in equilibrium. Why it is equilibrium? Because the pumpkin is not falling, or my hands are not going up, it is not going this way, that way. It is a stable condition. So I can see it is a equilibrium problem. So I will solve this problem. Okay, so let us I am holding it in this way. This cable is horizontal, this cable is inclined, and the pumpkin has some load. Okay, if I draw this, say my drawing is this. One cable is here, other cable was here, and the pumpkin was hanging like this. Say the weight of this pumpkin, how much? 2 pounds. So the weight of the pumpkin, say 2 pound. 2 pound. Okay, so I have a support here, I have a support here. Say this is C, this is A, this is B. And assume that this one is how much? 60 degree. I do not know. I just assumed a value. Say in this way, so in this configuration, my pumpkin is in equilibrium. If this is the case, and also this is say 90 degree. If this is the case, or if in this case my pumpkin is in equilibrium, what is the tension in this cable and in this cable or rope, whatever it is? So we need to solve it. So how to solve it? So to solve any problem related to equilibrium, the step number 1, draw free body diagram. Draw free body diagram. Step number 2, apply equilibrium equation. Apply equilibrium equation. So okay, so we can see that my pumpkin is here. This point is in equilibrium. So what I will do, I will draw free body diagram. How to draw it? Remove all the support, show the load. So I can remove that support and show a load here. Say this is TAC, tension at AC cable or rope. Say remove this support and show a force. Tension BC. Tension in BC cable or rope, whatever. Okay, so this is my free body diagram. So step number 1, draw free body diagram. Draw free body diagram. That is step number 1. Step number 2, apply equilibrium equation. Apply equilibrium equation. We might need only one equation or maybe more equation. What are the 3 equations we learned? Number 1 is summation of force in x-axis is 0, summation of force along y-axis is 0, summation of moment at any point is 0. So that is the equilibrium equation. We learned it. Now you should apply the equilibrium equation in a way that will give you some answer, some fruitful output. Do not just apply something, not like this. Be like creative or like think critically. So that is the smarter way. I very often I tell, do not work hard, work smart. So work smart. So I need to find this cable force and this cable force. If I apply summation of fx is 0, say this way, what are my forces this way? One force, and it has a component this way. So 2 forces along this way. I should not go that way because 2 unknown. 2 unknown I cannot solve at the beginning. If I apply summation of fy this way, how many force this way? the component of this force along this way and this force. This is known, this is unknown. Done, only one unknown. So that is this matter. So what I will do, I will apply summation of force. This means summation, F means force along y direction equals 0. How do I know equals 0? Because it is in equilibrium. And when I will sum up summation of force along y direction equals 0. And when I will sum up, I need to assume some sign convention. So I will assume any upward force is positive. Any upward force is positive and put it in the parenthesis. So you can write it down also that assuming upward force is positive. You can assume, or you can write this way. There is no universal term that you must do it. This is my style, and I saw most of the book, they follow this style. Okay, so upward. So this is my force, it is inclined. So what is the component of this force along this way? Is T BC sine 60 upward. Why sine 60? We know that adjacent to the angle is cosine. Perpendicular to that side is sine. So sine cosine 60 is upward, so positive. This 2 downward, so negative 2 pound is 0. Or you can write your unit here. That is a good practice to write unit. Then if I solve it, so T BC equals 2 pound divided by sine 60. 2 pound equals sine 60. If I use my calculator, sine 60, so 2 divided by sine 60, I got 2.3 pound. 2.3 pound. Yes, 2.31 actually, 2.309. So I got 2.30 pound, that is this force. Okay, once I find this force, now I can apply summation of Fx. Okay, I have no space here, so I will go up. Now I will apply summation of Fx equals 0, say this way, positive. What is this? Summation of force along x direction equals 0. Arrow that way, that means right side I am assuming positive. So that way positive. Okay, so that way the component of this force along this way, T cosine 60. So T BC cosine 60, that way positive. This force this way, so negative, minus T AC equals 0. Why I did not consider this? Because this is in vertical direction. I am taking in horizontal direction, so this force I will not consider. Okay, so make it simple. So T AC equals T BC cosine 60. T BC I found 2.30 pound, and cosine 60. Cosine 60 I know it is 0.5. So 1.15 pound. So hopefully you can see. Yes. So TAC I send the side, TBC cosine 60 is 2.30 pound, cosine 60 value is 0.5. So it becomes 1.15. So then I got two answers. So hopefully you understood how to apply equilibrium equation. So in our next video we will see one more example.